Hello students, now let us see the simplification of logic functions using the rules and theorems that we have discussed. We can use rules and laws of Boolean algebra to simplify the logic functions so that the logic functions can be implemented using less number of logic gates. If there are more number of logic operations in a logic function, then more number of logic gates would be required. If we simplify this particular logic function, then the logic operations in that logic functions will be less and less number of logic gates would be required. So before implementing any logic function, we go first for simplification of that logic function so that the cost of implementation will be less. So this reduces the cost of the hardware, that is the number of logic gates that are required for implementation of that particular logic function. So for example, we shall see this simplification of a and b and c, or a and b, or a and b and c bar. So we can go for the solution of this. Let us see this solution here in this tabular form. First of all, we take a and b common from the first and third term. We can see here that in first and third term, a and b is common. So taking common from those terms, what remains in the first term is c, and what remains in the third term is c bar. So it will be c or c bar. So this is how we are writing the first and third term by taking a and b common. Then or a bar and b, second term is written as it is. Then ORing using the OR rule, that is a or a bar is 1, so it is applied to this c or c bar, it will be 1. So you can write c or c bar is written 1. Then we can write a, and you can use the rule a and 1 is equal to a. So here we have to treat this as a single variable. So uh, anything ANDed with 1 is same thing. So here we are ANDing a and b, and so it will be a and b. So you can see a and b ANDed with 1 is a and b, whereas the second term is written as it is. Now taking b common from first and second term, that is using the distributive law. So after we take that common, what remains in the first term is a, what remains in the second term is a bar, and again we can use the OR rule, that is a or a bar is equal to 1, so that b, it will be b and 1, a or a bar replaced with 1, and again using the rule and rule, a and 1 is equal to 1, so this expression reduces to b. So this particular big expression, when we simplify, it reduces only to b. So with this we come to the end of this particular topic, Boolean algebra. We have seen binary operators, basic rules of binary operations, laws of Boolean algebra, De Morgan's theorem, simplification of logic gates. In the next topic we shall go for logic minimization using the K-map technique. We shall see the logic functions also, how they can be represented in the truth table form or the uh, SOP, that is sum of product forms, and the other forms. So thank you.